5 minutes to places. We have 5 minutes to places.
5 minutes to places.
My name is Jessica. I am new to this podcast. I am a second year in the Theater Management MFA program here at Wayne State University. As we return back to the world of in-person theater, we are incorporating a small twist into our podcast. Moving forward, you can plan to hear from us, highlighting aspects of the shows we are working on here at Wayne State University. Before we dive into today's episode, we wanted to start with the acknowledgement that we are all living on stolen lands. Wayne State University rests on Wahweapnong, also referred to as Detroit, the ancestral and contemporary homeland of the Three Fires Confederacy. These sovereign lands were granted by the Ojibwe, Ottawa, Potawatomi, and Wyandot nations in 1807 through the Treaty of Detroit. Wayne State University affirms Indigenous sovereignty and honors all tribes with a connection to Detroit. With our Native neighbors, WSU can advance educational equity and promote a better future for the earth and all people. Today, we are going to focus on the lottery aspect of this production because that's a lot to unravel. 5 actors had to memorize 5 entirely different roles and won't know which role they are playing each night until the show has already started. That sounds a little intense. Emily, who you might remember from previous episodes, also happens to be my classmate and colleague. She started thinking long and hard about the probabilities involved with this production and started to break down the basics for me. Each actor has an equal chance of being selected in each round of the lottery. Once an actor is assigned to a role, they are not considered for the remaining rounds. The final actor who has not been assigned to a role will play the final role available. We spent a lot of time talking about these probability factors in the theater management office this semester, but let's face it, we aren't math whizzes. Lucky for us, Emily's brother AJ is a senior at Grand Valley University with a major in statistics and applied mathematics. What are the odds? Emily graciously offered to talk to her brother about the probability behind everybody to help us break down our chances of seeing each performance mix a little bit more.
Hi, AJ. Thank you so much for meeting with me today to talk about everybody and the statistics and the probabilities behind the in-show lottery system, because that's the thing that makes this production and this show so unique, is the fact that for some of the actors, they don't know who they're going to be playing until the night of the show when that lottery is done. So we have 5 actors that participate in this lottery, and there are 5 different groups that they can be sorted into. So they did the math, and they tell us that the chances of seeing any of those shows are 1 in 120. So there's 120 different shows that could happen. So how does that math work out? How do we know that?
Yeah, so basically, in simple terms, the combination that you have for these 5 different groupings and how they could be split up is basically just 5 factorial. And if you don't know what that means, that's basically just means 5 times 4 times 3 times 2 times 1. So every single time for those different steps, you are multiplying it basically just like a fraction, just like 1 over 5, 1 over 1 over 3, 1 over 2, 1 over 1. And that ends up being this 1 over 20 number, which is the possibility that, or it's the amount of different roles all of these actors can play throughout the week of the shows.
What I'm wondering is, what would be the odds then of seeing the same show twice in a row? Do you think that could happen?
So the odds of that are very low. So if you have 120 different shows, basically the probability that you see one specific show in a night is 1 over 120. To figure out the probability of seeing that twice in a row, you'd basically just do multiplication of fractions. So if I were to see the same night in a show, so the same 1 out of 120, you would do 1 out of 120 times 1 out of 120, which ends up being 1 out of 14,400, which is an extremely low probability, basically saying that if you're going to see 7 shows in 7 nights or whatever number, I can't remember for sure. Basically, if you were to see 2 shows of the same type, somebody probably planned it out that way.
That's good to know. That's interesting. Yeah, you should probably go buy a lottery ticket too.
Basically.
Yeah. Thanks for explaining the math. Do you think that you could just tell us a little bit about you and like your background and like why you're here telling us about statistics stuff?
Yeah, absolutely. So right now I am currently an undergraduate student majoring in statistics and applied mathematics at Grand Valley State University. So I'll be graduating this year with my undergraduate degree, and I'm also related to you. So you're my big sister. So how else would I love to repay you, but to help you with some stats for your show? So I hope it helped.
Well, you were the first person that I called, and it was great to get to talk to you then, and it's great to get to talk to you now.
This is just a combination problem. So 120 over 11 is basically saying there's 120 shows and I see 11 different shows, but the order doesn't matter. So it's not order centric. And the math for that is kind of annoying, but it's basically just 120 factorial over 11 factorial, and then it's 120 minus 11 factorial, so 109 factorial, and I would never solve this with the calculator.
Gotcha.
Multiplied by 11 over 120, and then the same thing on the bottom. So
quick question, is the 109 factorial being multiplied by the 11 factorial?
yes.
Okay, cool.
And then the same thing, kind of pattern.
Is that an 11 factorial at the beginning?
That's the 12.
That's a 12 factorial, okay.
Yeah, that's coming from here.
Gotcha.
So it's just the denominator instead of the numerator.
Okay.
And then I'm gonna let my calculator do the math for that, because so it basically comes out to be, I'm gonna write it up here. You have like a 1% chance,
Okay.
which makes sense because you have, you see 11 different shows and then you show up, and there might be a better way to display that situation. I feel like maybe not. Yeah, it's about a 1% chance.
I think it works though. It's like you attend every single performance of everybody.
Yeah, you attend 11 performances, and 120 is not that like out there. There's that many combinations. Like, it's a large number, don't get me wrong, but
So if you attend every performance, then your odds of seeing the same show twice just at some point become 1%.
yes,
Cool.
it's like after you've seen 11 shows.
Gotcha. Right. If you have to,
It's not 1% chance that you see the same show.
Mhm.
It's 1% chance that you see the show after you've seen 11.
Yes.
Mhm.
Gotcha. And that could happen like, so let's say, so you see all of the shows. So show 12 could match show 1 or show 2 or show 3, show 4, show 5, and so on,
Yeah.
right? It doesn't need to be
Yeah.
show 1.
Yep.
Cool. I think that's all I have for stats questions. AJ, thank you again, like so much for doing this.
Wow. So the opportunity of seeing the same performance 2 times is 1 out of 14,400. To put that in perspective, according to researchers published in the Scientific Reports Journal, the highest probability that humanity goes extinct from natural causes in any given year is 1 in 14,000. So we have a higher chance in going extinct this year than you do of seeing the same show layout of everybody twice. I say take your chances and come out to see this show. Everybody is performing in the Hilberry Theater at Theater and Dance at Wayne State University, October 1st through 16th, 2021. Tickets range from $15 to $22 and can be purchased online at theateranddance.wayne.edu, by phone at 313-577-2972, or in person at the box office up to 2 hours prior to performance times. Thank you for tuning in to 5 Minutes to Places. We hope to see you in person again this season and in the audience of everybody this month. If you like what you heard and you listen through Apple Podcasts, please leave us a rating and a review. Thanks for tuning in.